Alright, today, real world application begins. So please make sure you're paying attention on this. You've got this down. What we're looking at here is we're looking at two interest formulas that you're going to see on this day one activities worksheet. Continuous interest you already know. Compound interest is the new one today. You've got your total amount, your principal. 1 plus is a constant. It'll always be there. 1 plus the rate divided by the number of times that you compound the interest in a year, more on this later, raised to the number of times you compound in a year times t, time in years. This formula right here will be the difference in you paying somebody for the rest of your life or having your money work for you. Please do not be a slave, a financial slave to anybody else. And I'm speaking from personal experience here. So please make sure that you avoid the same mistakes that I made by paying attention to this particular set of problems. Because this is legalized stealing, and there are people waiting for you to turn 18 so that they can begin this process on you. Okay, while in 6th grade, Heater, I'm going to say that that's supposed to be Heather, she wants to invest $20 in a bank account, paying annual interest. The reason I'm focused on that is that that is where your N comes from. Alright? She has a term here of 50 years, and we need to know how much is going to be in the account. Alright, so she invested $20. That's your principal. Remember, 1 plus is always your constant there. We've got 6% annual interest, so the rate expressed as a decimal is 0.06. N stands for the number of times it's compounded in a year, and annual means 1. And then we're going to do 1 times 50. So what I like to do is I like to do this part in parentheses first to avoid any confusion with my calculator. Alright? Then once I have that, I raise it to this power right here. So it's 1.06 raised to the 50th power. Then I'm going to multiply that result by 20. And that's going to give me 368.4. Alright, number 2. Estimating the time it will take an investment, that's our principal, to double in value if it is invested at 8% interest. Alright, so that means the double here is the key to my amount. So 25 times 2 is 50. So 5,000 is my amount here. And then I've got my 1 plus the 0.08. Remember, nothing was said about how many times it's compounded, so it will be compounded annually. So now I'm going to go ahead and figure this out by simplifying this part down. You don't have to, but it's kind of a neat little quirk of these problems, which you may find useful later on. That's going to be 2 equals 1.08 to the t power. Remember our switch, so we're going to make that little switcheroo there too. Log base 1.08 of 2 equals t. Calculating that using the change of base formula, or if your calculator has that function, you get t is 9 years. Make your money work for you. Do these calculations before you go to a bank to determine where you want to put your money into. Figure out what fees and what other interest rates they charge on those accounts before you start giving away your money to other people. Alright, an investment made in a trust fund at an annual percentage rate of 12%, compounded monthly. How many times does a month happen in a year? That's 12. So your N is 12. How long will it take for the investment to reach $2,000? So we're going to go 2,000 equals 1,000. Again, we're doubling the amount, times 1 plus, excuse me, 12%, 0.12 divided by n, the number of times it's compounded, 12, and that's 12 times t. Divide out your 1,000 first to make your calculations easier, and that gives me 2 equals 1.01 if you do this parentheses, and then you get 12t. Moving this number first makes your calculations a lot more manageable. So please always look at this when you're solving for any variables inside of this part of your compound interest formula, and move that number away first. It makes this number smaller and more manageable, as well as getting this conglomerate of numbers alone by themselves, so that you can actually make the switch from exponent form to logarithmic form a lot easier. So please pay attention to this. That should always be your first step when solving for a variable which is located either in the rate, the compounding, or the time on the right side of the equation. So now I'm going to get log base 1.01 of 2 equals 12 times t. I'm going to go ahead and divide out my 12 to the other side. Again, you know, you can do this problem first using the change of base formula or the calculation in your calculator if you have that. All right. So how long will it take the investment? It's going to be approximately 5.805 years. All right. More importantly, if you're going to determine whether or not you want to use credit cards for your purchases or not, please do these calculations so you understand how long it's going to take you to pay off that t-shirt and jeans and video games and all the other junk you think is important instead of investments. Okay, so please take a look at it and make sure you understand the ramifications of the choices you make when you take out a loan from a credit card company, because they are going to count on the fact that you aren't doing these calculations and therefore don't understand the length of time that it takes to pay off total amounts that have interests connected to them. So continuing on, Emma receives $7,750, invests it at 4% interest, and here's our key: compounded continuously, back to P-E-R-T, PERT. So we need to know the total amount of the $7,750 multiplied by E raised to the 0.04 power times T, which is 5. This one's a very simple problem because you just type it in exactly the way you see it in your calculator, and we get $9,465.87. Question number 5. We invested $1,000. There's our principal. Has an APR compounded daily based on a bank year of 360 days, not 365. And you want to have $2,500 in the account by the end of the investment. We need to now determine what interest rate we would need for 10 years. So this is for that time when you're offered a loan and you'd like to negotiate that, and you want to know what interest rate will either help you the most or hurt you the most. Okay, so here we go. We're going to start with $2,500 equals $1,000 times 1 plus, remember that's your constant inside of the compound interest formula, the rate, which is unknown, over 360 raised to 360 times 10. Remember, we're trying to get this group of numbers alone, so we're going to begin by dividing both sides by 1,000. we get 2.5 equals 1 plus r divided by 360 raised to the 3600. Alright, it's at this point where we would normally switch into its other form, but we can't do that this time. And the reason we can is because this is the base of the exponent, which means if I were to switch into log form, the base would have the variable in it, which makes no sense at all. So I've got to use a different property of logarithms, and that property of logarithms is to add a log to both sides of the equation. Remember, by adding a log to both sides of the equation, we change nothing about the problem, except for the fact that we can now use properties of logarithms to remove the exponent from the problem. We use the power property of logarithms at this point to bring it out in front, and we get log of 2.5 equals 3,600 times log of 1 plus r divided by 360. Now I can divide this out to the other side. And now I get a very teeny number, 1.105 times 10 to the negative 4th power. That equals the log of 1 plus r divided by 360. Now what I'm going to do is I'm going to switch it back from log form into exponent form again. And the base of this logarithm is 10. Here becomes your exponent. This argument is what it's equal to. It gets a little bit tricky at this point, so be very careful about what you're doing. Okay? Let me show a small example before I move on. Let's say, for example, the number is 4 equals log of 6. So that means what I'm going to do is 10 to the 4th equals 6. Completely, I guess I should have put an x here instead. Sorry, let's make it an x so it actually makes sense. We're just switching it into its other form. Alright, so now it's going to be 10 to the 1.105 times 10 to the negative 4 power equals 1 plus r divided by 360. This gives me 1.00 approximately equals 1 plus r divided by 360. Subtracting 1, now you realize this is a very much an estimated answer. Okay? 2.5456 times 10 to the negative 4th power equals r divided by 360. Multiply both sides by 360, and my final answer is r equals 0.09 or 9% interest. Please take a look at this problem in detail and make sure that you understand how it's solved before we move on in tomorrow's lesson during class. Now you can see why people make so much money off of unsuspecting victims, because nobody wants to go through this hassle just to find an interest rate that works best for them. And finally, question number 6. Please go through the steps to determine how many years it's going to take to find to get these two amounts of money. Notice that there are two different ways that this person wants to, or two different numbers that this person wants to get to, either 20,000 or 30,000. So you're going to have to solve once for the lower edge of the range, and then you're going to have to solve again for the upper part of the range. Please be prepared to share your answers with question number 6 tomorrow with your group mates.